It's all you.
Let's just go around in a circle. Oh, so. Okay, so as you can see by our data, for the volume, we took 3 trials for both the volume and the mass. We got the same volume on all 3 of our trials, which is pretty cool, 45 milliliters. And then the mass, we're all like sort of in the right similar range. We thought that maybe some pieces chipped off or whatever, but our average was 3.06 grams. And so from that, those 2 data sets, we concluded that the density is approximately 0.068 grams per milliliter. So that was our claim.
Can I ask a question?
Yeah.
So regarding your mass, is that the change in mass or?
Change in mass.
Okay.
Yes, Vaughn.
Just a clarifying question, so you only did the mass one?
Well, that's the volume.
Oh, okay.
Volume serum mass.
It was the
Oh, is
change
that
in
the
volume
volume
and
change?
the change
Oh,
in the
okay.
mass.
Alright.
So where are we gonna go?
This way.
This one.
Why?
Alright.
Okay, so this is our data set. The second set of data isn't that accurate because it took a while for us to get the Alka-Seltzer underneath the beaker or whatever. Our volume before is kind of in the same range. It's in the 500s, but not that close really. And our volume after varies enough. Well, with those two, it's kind of in the same range. And our claim, we said that we don't have enough data to make a claim yet.
Yeah, so we thought, like, I mean, I think our data set's like, it's in a work in progress, but it's not bad because our Alka-Seltzer is all like the same. It's all like really close to each other. And then our volume before is like, it's all within 50 centimeters cubed, so that's pretty close. And the only thing here is just, we didn't, as you said, didn't put the Alka-Seltzer in under the beaker like before it fizzed away. So that was the only problem there.
Yeah, it kind of throws off the whole data set, but 2 out of 3.
Yeah, thank you.
Okay, so we did 3 trials for the mass and 2 trials for the volume. We kind of got crunched on time, so we kind of separated on it. But so here we record it in a way that's like we record the Alka-Seltzer, the water, the Alka-Seltzer, the water, and then the mass after all of that. And then
We also, there's one trial that I think was slightly off, in which the mass after was greater, which doesn't make sense because gas escaped, so it should be less. I think our other trials were better than that, but the first trial, I think we probably had water that dripped in, or we just, the scale was off, which I doubt. But for the volume, they were pretty similar, 54 and 55. It took me a while to figure out how to actually do it without letting the tablet escape, so we only had 2 trials. Yes.
How many attempts did you make before, like besides those ones?
For the volume or the mass?
the mass we did 1 before, but then we realized we did it wrong. So we only put 3 of them, but the first one was a complete fail, so that's why we didn't record it.
And then for the volume, I couldn't get the aluminum flipped without spilling a bunch of water, so that took me a few tries. Yes.
So do you have any so are these all mass trials? Do you have any volume trials?
Volume is on that side.
And then which one's mass?
This side.
There's
Oh.
a variety of measurements
Yes.
taken.
And so our claim is that we didn't get enough data to make a claim yet.
Okay, let's keep going. See what we can.
Right. So we took 2 pieces of each of the volume changes and the mass changes of data, and our claim was because the water is gaining because the water is gaining mass but losing volume, and the air is gaining volume but keeping the same weight, the air is gaining density when dropping the Alka-Seltzer, or losing density.
Can you explain that?
Yeah, can you
Yeah,
explain
sure.
that a little
So
further?
basically, we did it. We didn't have enough data to create the mass average, so we like observed what,
Trend it follows.
yeah, and we observed that the air was losing density and the water was gaining density.
Okay. So like we didn't have enough data to get a claim because we didn't do the mass, we just did the volume. And we did 4 trials with the volume, and our like difference was 140, 140, 100, 100, and
We recorded 5 trials for both mass and volume, but we didn't record enough, and our data had a lot of outliers, so we think that we don't have enough data, enough like correct data to actually make a claim.
For our data, we also recorded the mass and volume of the Alka sensor, and we had 5 trials. We only had 1 outlier, which we think was pretty good, so our data was nearly correct, and we got all the densities of our of the Alka sensor, so we know the density of the gas.
okay. So we did 2 trials of each one. In our first volume trial, I don't really know what happened, but we got 33 milliliters, which is very different from the 104 that we got in the second trial. And then our mass ones were similar. But yeah, I don't really know what happened with the first one. I think it dissolved before we could get it under the.
So we didn't get to the volume because we ran out of time, so we just did the mass. And we all got roughly consistent, basically the same, but for all of them.
And because like we only did like the mass, and we didn't really do that many like experiments of it, so we don't really have enough data to make a claim.
Do you want me to? Here, I'll flip it so the camera can see it. So we did, we only did the mass because we didn't have enough time to find the volume, but we found that our data had a lot of outliers, just like Johnny and Catherine's. So we think that we might definitely redo our experiment in next class, just so we can confirm and get better data. But we made a histogram on the trials, and they were like pretty. I mean, they look similar, but for some reason our buckets were kind of weird. So yeah, we did have a claim, but it was really just finding the mass of Alka-Seltzer. It wasn't really, it wasn't in terms of density. We just like made a claim based on the mass. So yep.
Well, we did decide to do 3 trials for both the mass and the volume. And for the volume, we found that we had 2 kind of in the same ballpark, and then we had 1 that was kind of an outlier. And the same was with the mass. These 2 were in the same ballpark, these 2 were in the same ballpark. This one was kind of an outlier. But our main question was, we were wondering why the change of the volume change. We wondered if the gas had a change in the volume.
So the outlier, like it was trial 2, right, for both of them?
Mm-hmm.
So then would you say that
That's
it
trial
was
1.
like proportionally outlying? So like they have the same ratio, but they're like,
First one was the first one.
Yeah.
oh, okay.
Yeah.
Right, never mind.
Does anyone have other questions for people?